All right, today's lesson is going to be 3.4b. I decided to extend the lesson a little bit today because I don't feel like we got to cover solutions the way that we needed to cover them. So take a moment and pause the video and write down your objective and take care of your table of contents. All right, the first thing we want to do is talk about what is a solution in math. Well, in real life, a solution is something that makes a problem work. If I have a problem and I find a solution to it, that means my problem no longer exists. Everything's okay. Well, in math, a solution to an equation is a value that, when you substitute it back in for the variable, it makes the equation true. So go ahead and copy the definition of solution into your notebook so that you have it for future reference. All right, so I'm going to go back to way back to the beginning when we started solving equations and start talking about solutions from that point forward. So maybe this whole thing will make a little bit of sense to you. So when we solve this equation, 2x plus 1, the first thing I'm going to do is I'm going to subtract 1 from both sides. That will give me 2x equals 2, x equals 1. Well, x equals 1, if this is truly a solution, then when I plug 1 back in for x right here, I should get 3. So let's see what happens. 2 times 1 plus 1 equals 3. All I did is take this 1 right here and substitute it in for x right there. And 2 times 1 is 2, plus 1 equals 3. So that does check. So then we can say that 1 is a solution. 1 is a solution. What would happen if I plugged a number in and it came up as not true? Say, for example, if I plug in 2 for x. So if I just pick some random number, like 2, and plug it in for x, that's going to give me 4 plus 1 equals 3, which comes out to be 5 equals 3, which is not true. So this is a non-solution. Okay, so if it makes the equation work, it's a solution. If it doesn't, it's a non-solution. It's kind of like a true-false. If it works, the equation is true. If it doesn't work, it doesn't work. It makes it false. All right, let's try one more. 2x plus 3 equals 9. Subtracting 3 from both sides. That's going to leave me 2x equals 6. And then I have to divide by 2. X is equal to 3. So if I take this 3, x equals 3, and plug it back in up here at the top, let me erase this out a little bit here. I plug it back in at the top, so 2 times 3, I got a dead spot up here. 2 times 3, let's start over, something's going on here. 2 times 3 plus 3 equals 9. So 6 plus 3 equals 9. That checks. 6 plus 3 does equal 9. What if I plug in 4? 2 times 4 plus 3 equals 9. That's going to give me 8 plus 3 equals 9, which is 11 equals 9, which is not true. So 4 is not a solution. So 3 was a solution. 4 is not a solution. All right. So number lines, we talked a little bit about those yesterday, about solutions and non-solutions of number lines. So my equation says, or my inequality says, x has to be less than or equal to 11. So a solution would be any number that's less than or equal to 11. So a solution would be this part of the shaded graph. So any number that's in the part of the shaded graph, I could plug it in for x, and it would be a solution. For example, if I plug in 10, 10 less than or equal to 11 is true. 10 is less than 11. 0, way down here, 0 less than or equal to 11 is a solution. That's true. So any number I plug in that's less than or equal to 11 is going to be a solution. A non-solution would be any number that's on the other side that is not shaded. For example, if I plug in 14 into the equation, if I plug in 14 for x here, that's going to give me 14 less than or equal to 11. And 14 is obviously not less than 11, so that would be a non-solution. I could plug in 100 way down the road down there. If I plug in 100 for the equation, that would leave 100 less than or equal to 11, and that is not true, so that would be a non-solution. Okay, so now we're going to start talking about solutions of linear functions. A solution of a linear function is any xy point that lies on the line. So let's try a couple. Let's pick a couple of points that are on this line over here at the right. Let's try this one. Let's try this one, and let's try this one. And let's see what happens when I plug those points in. So my first point that I selected is at -4, 1, 2, 3, -3. My second point that I selected is at -1, 0, and my third point that I selected is at 2, 3. So let's just see what happens when I plug those points in my equation. So my first equation, or my first attempt, is going to be this guy down here. So in for y goes -3, in for x goes -4 plus 1. Well, -4 plus 1 is -3, so that checks. All right, let's try the next point. In for y is going to go 0. In for x is going to go -1 plus 1. And -1 plus 1 is 0. That checks. All right, my last attempt. I think you guys are starting to get the idea now. If I put in 3 for y and 2 for x, 3 is equal to 2 plus 1, so it checks. So any point, I could pick any point on this line and plug it into that equation, and it would give me a true statement, which means it is a solution. So let's go the reverse now. Let's talk about a non-solution. If I choose any point that is not on the line and plug it into the equation, it is not going to be the solution. The solutions only lie on the line. So let's pick a point, real easy one to plug in, 0, 0. If I plug in, let's write it on there. If I plug in 0 for y and 0 for x, you can clearly see that those are not equal to each other. Let's try another point that's not on the line. Let's try this point right here, which is 3, 0. So when x is 3, y is 0. So I'm plugging in 0 for y, plugging in 3 for x, and that says 0 is equal to 3 plus 1, which is 4. That is not true, so it is not a solution. So any point that I choose that is not on the line, I could pick one up here, or I could pick one like way over here someplace, or way down here someplace. Any point that is not on the line is going to be a non-solution. All right, this is very similar, same thing. I have another equation, 2y equals 2x plus 1. So I could choose any one of these points and plug them in to my equation. So let's try this one. I'm going to try this point right here. I could plug in 7 for y, because this is my x, this is my y, equals 2 times 3 plus 1. That checks. I could plug in, let's try another one. Let's try this 0, 1. This is x, this is y. So in for y goes 1, in for x goes 0. So 1 equals 2 times 0, which is 0 plus 1, so that checks. 0 plus 1 is 1. So you get the idea. Every point on this line is going to be a solution. Every point. And I'm not talking about just the points that are the nice, neat, pretty points. I'm talking about the in-between points, too. Points can be fractions. You don't typically use those in Algebra 1, but sometimes you might. But you need to know that all the points in the line, on the line, are solutions, even if it's not an integer. Okay? It could be a fraction or a decimal as well. All right, so here I have a table of values that I want to find out if the table of values are solutions to the equation. So what I have to do here is I have to use my equation, and I'm going to take each of these points and plug them in and see if they come out to be a true statement. If it's true, then it's a solution. If it's false, then it's not a solution. So the first thing I'm going to do is I'm going to plug in my first point where x is -2. This is a point right here, -2, comma, -2. So I'm going to take that -2 and plug it in for x and for y. All right, let's see what this does for me. -2 equals 2 times -2 is -4 plus 2. And -4 plus 2 does equal -2. So that one checks out. So this one is a solution. All right, let's try the next one. This is my x, this is my y. So in for y goes 0. In for x goes -1 plus 2. 0 equals 2 times -1 is -2 plus 2. And -2 plus 2 is 0, so that one also checks. All right, 2 down, 2 to go. All right, this one I'm checking when x is 0, y is 2. So when y is 2, plugging in 2 for y, plugging in 0 for x. 2 is equal to 0 plus 2. That also checks. All right, and then let's try this very last one where x is 1 and y is 4. So 4 goes in for y, 1 goes in for x. 4 is equal to 2 plus 2. That also checks. So each one of these points is a solution. So not only when I plug the points in does it make the equation true, but you have to consider the graph as well. So each of these 4 points, -2, -2, -2, -2, which is here, -1, comma 0, which is here, and 0, comma 2, which is here, and 1, comma 4, which is up here. Okay, all those points are on the line, and this graph is the graph of the line. If you remember how to graph a line, has a y-intercept of 2, which is right here, and then has a slope of 2 over 1, so up 2 over 1. So each one of these points is on my line, and it makes the equation of the line true. So it's all intermingled like that. You need to have a good understanding of that. All right, let's try this guy. So I've got y equals 2x minus 4 is my equation. All right, my first point is x is 1, y is -2. So -2 goes in for y. 1 goes in for x. So I have -2 equals 2 minus 4. -2 equals -2. So that one checks. This one's good. All right, let's try another one. 0, comma 4. So y is 4. X is 0. So 4 equals 0 minus 4. So now I have 4 equals -4. This one does not check. Okay, so this one is a no. All right, next one. 3 and 2. X is 3, y is 2. So 2 goes in for y, 3 goes in for x. That's going to give me 2 equals 6 minus 4. 2 is equal to 2. That one checks. All right, last one. When x is 2, y is negative 3. So y is negative 3, x is 2. That's going to give me negative 3 equals 4 minus 4. Negative 3 equals 0. That does not make it a true statement, so this one is a no. All right, so let's talk about what that means graphically. I know that there's 2 points on that table there that are not solutions to my equation. So if what I'm telling you is true, then those 2 points, 0, 4 and 2, negative 3, should not lie on the graph of the line. So let's see what that looks like. All right, so first of all, let's make sure this is the graph of the line by checking the slope and the y-intercept. So I have a y-intercept of negative 4, which is here. I have a slope of up 2 over 1, so up 2 over 1, up 2 over 1, so that checks out. So far, that looks like everything's correct. And from my table, this point should be on my line, 1, negative 2, 1, negative 2, there it is. And 3, 2, 3, 2, there that point is. So those 2 points actually did end up being on my line. Okay? Let's check these other 2 that didn't work. So let's see, I've got 0, 4. 0, 4. Let's see what that looks like. All right, so over here, 0, x is 0, y is 4. That point is up here. It clearly is not on that line. And when x is 2 and y is negative 3, x is 2, y is negative 3, that's down here, also not on the line. So for it to be a solution, it has to make the equation true and it has to be on the line. If it doesn't fit either one of those criteria, then it is not a solution to the linear function. All right, I want you to stop there and I want you to complete the worksheet on solutions of linear equations.